The spread of misinformation as seen through the lens of compartmental modeling approach presented by Group 1. Outside of the four corners of a classroom, not every human being has the capacity to educate themselves on how to become literate in consuming and producing media messages. We believe that everyone should be taught on how to become media and information literate, since our concept of truth and the quality of how we live our lives significantly depend on what media messages we consume and share to the rest of the world.
In this video, we will try to use the compartmental modeling approach and apply it to the topic of the spread of misinformation, specifically on social media. We will discuss the model assumptions first, then the model variables and parameters. Next, we will show a figure to illustrate the model using the compartmental modeling approach. Then finally, briefly discuss about the possible solution approach.
Before showing the compartmental modeling, we'll first state our assumptions in building the model.
First, the whole population can be divided into three subpopulations: less vulnerable, the highly vulnerable, and the misinformed. By highly vulnerable, we mean that this particular subpopulation is highly vulnerable to becoming misinformed, perhaps because of the lack of media and information literacy skills. Consequently, the less vulnerable, we mean a particular subpopulation with fair media and information literacy skills. Second, when people turn 12 years old, they enter the system through the highly vulnerable subpopulation V sub 1. People with ages beyond 12 to 70 years old are not considered to participate in the system. Third, the social media influence is done through posting and sharing contents online.
The per capita social media influence rate delta exerted by V2 towards V1 and M is the product of the number of interactions and the infection probability of each interaction. An interaction is described as the total number of times people saw, liked, or shared the certain content. The per capita rate at which people become misinformed alpha is a product of the contact rate, or the number of interactions made by the social contents of M, and the infection probability, or how believable the content's delivery was.
Model variables. There are three variables involved here: V sub 1, V sub 2, and M. What we mean when we say less vulnerable subpopulation is the fraction of the population who are media and information literate. These are the people who are aware that the contents available on social media are just constructs needed to be validated. The misinformed subpopulation is the fraction of the population who are consuming and sharing misinformation online. The highly vulnerable subpopulation represents those who haven't yet honed their media and information literacy skills, making them the most prone to easily be deceived by misleading contents online.
There are four parameters used in the model, as summarized in the table.
Now, we will be presenting a figure illustrating the model.
Model illustration. The links describe the corresponding inflow and outflow in the compartments.
We have three compartments: V sub 1, V sub 2, and M. The system is populated through V sub 1. Then, V sub 1 can become misinformed M by the factor alpha. However, V sub 1 can also become less vulnerable V sub 2 by delta. Next, the misinformed M can also become less vulnerable by delta, and the V sub 2 can become misinformed 2 by the factor alpha. Finally, there is a constant rate of leaving the system mu.
The following shows the model as a system of differential equations.
Finally, in finding a solution, the system of ODEs presented can be solved numerically using applications like MATLAB Numerical Solver or in Python, provided that we already obtained decent estimates for the parameters listed above, as well as the initial conditions for the three variables involved.